the magnetic rubbing experiment. Hi, I'm Rofi Wafa with ID number 20055880 from IPSE FMPOP. So here, I would like to explain about how to make a magnet. There are several methods to make a magnet. The first method is rubbing method, the second one inductions, and the last one is electric current. So in this experiment, I will make a magnet by the first method, which is rubbing the magnet. So here's the equipment that needed for doing the experiment. The first one is a magnet. The second one is a nail. And the last one is the paper clip. Procedures. Take the strong magnet in one hand. With a firm grip, rub one end of the magnet along one side of the material in a consistent directions. Repeat the rubbing motions multiple times, applying pressures. The more strokes, the better the alignment of the magnetic domains. After rubbing for a sufficient duration, set aside the magnetized material. To test the magnetizations, bring the magnetized material close to the small metal objects like paper clips and observe if they are attracted to it. If desired, you can repeat the process to enhance the magnetizations further. So how can it happen? The rubbing method of making a magnet involves the alignment of the magnetic domains within a material. Magnetic domains are regions within a material where groups of atoms have their magnetic fields aligned in the same directions. In an unmagnetized material, these domains have random orientations, resulting in a net magnetic field of zero. When a strong magnet is rubbed against the material, the magnetic field of the magnet interacts with the magnetic moment of the atoms in the materials. The repeated rubbing motions provides energy to the materials, allowing the magnetic domains to gradually align in the directions of the applied magnetic field. As the rubbing continues, the magnetic domains within the materials start to align and become more coordinated. The alignment process involves the rotations and realignment of the atomic magnetic moments within the materials, which can be influenced by the magnetic field of the magnet. Eventually, with sufficient rubbing, the magnetic domains become more uniformly aligned, resulting in a net magnetic field within the material. The material becomes magnetized, with one end having a north pole and the other end having a south pole. This alignment of the magnetic domains enables the materials to attract and interact with other magnetic objects. It's important to note that the magnetizations achieved through the rubbing method is usually temporary. Over time, the magnetic domains within the material may gradually revert to their random orientations, causing the magnetizations to weaken or disappear. So that's all for this experiment. Thank you for listening and see you in another mind-blowing experiment.